Lesson 1-2, Order of Operations and Evaluating Expressions. Hopefully, as you look at this screen, you recognize something that you've seen before. These letters spell out something called PEMDAS. You might recognize the acronym PEMDAS. I've just added an R. Pause your video for a second and see if you can remember what each letter stands for. All right, just to review, P stands for parentheses. Those are our grouping symbols, sometimes like that, sometimes brackets. E stands for exponents. R is a new one. R stands for radicals. It's new to us this year. A radical is anything that involves a square root. So if you can see in this image I have here, there's a square root sign over this heart. A little more information. This image is kind of fun because when you have a square root sign and the square root of 2, these cancel out. So really this just says I heart math. All right, we know M stands for multiply, D stands for divide, A for addition, and S for subtraction. So this is the order we want to do things when we are simplifying an expression and remembering to use order of operations. All right. Before we get into our PEMDAS, we're going to talk a little bit about powers. Powers are used to shorten how we represent repeated multiplying. So instead of saying 2 times 2 times 2 times 2 and so on, we can write it as a power, 2 raised to however many times it's being multiplied. So this right here is a power, 2 to the third power. The base is 2 and the exponent is 3. When we simplify a power, they want you to take that power and write it out like this, and then find out what that actually is. So 2 times 2 is 4, times 2 is 8. That would be the simplified version of this power. Let's do 2 together. If I have 10 to the 7th, I can write that as 10 being multiplied 7 times. If I have 2 tenths, I can multiply, or to the 5th power, I can multiply 2 tenths together 5 times. And then I can go a step further and find out what that actually equals. This case is 10 million, and here is 0.00032. So if I were to do another example, 3 to the 4th power is like multiplying 3 4 times. And when I do that on my calculator, I get 81. 2/3 to the 3rd power, same thing with fractions. You just multiply them as many times as it tells you by the exponent and use your calculator to solve. All right, now, different from powers, when we simplify an expression, we just need to perform operations in the correct order. So if we look here at this first example, I have 2 plus 3 times 5. I have addition and I have multiplication. An average person might look at this and add first. 2 plus 3 is 5 times 5, and they get 25. That's not the right answer because they didn't remember order of operations. We know we need to use multiplication first. So we actually multiply 3 times 5, which is 15, add the 2, and we get 17. So it's important to follow the steps. This key concept is important to have in your notes. Just remember that perform any operations inside grouping symbols first. So even if you have to add and subtract first, it's okay as long as it's in a grouping symbol. Sometimes a fraction bar also acts as a grouping symbol. Meaning if you have something in a fraction, like 5 plus 2 over 3 plus 1, even though we don't usually do addition first, because it's over this fraction, you want to take care of both the top and the bottom first before you divide. And then after that, simplify powers, multiply and divide from left to right, and then add and subtract from left to right. Here we go, let's do an example. All right, example A, 6 minus 2 to the 3rd power, divide by 2. So if I get my PEMDAS, I don't see any radicals, so I don't need to think about my R. First, we do parentheses. 6 minus 2, that equals 4. Then we do exponents. 4 to the third power is 64. Then we divide. 64 divided by 2, 32. Here's one with a fraction. So we're going to take care of the top and the bottom first. The bottom's already done because we're already at 5. But 2 to the 4th we can simplify and we get 16. Do the subtraction first. 16 minus 1, get your 15, and then divide. So it's a little bit backwards, but because there's that grouping fraction bar, we have to do the subtraction first in that case. All right, one more example here. Let me do C, since it's another fraction bar. So 4 plus 3 to the 4th. Well, I need to know what that equals. So 3 times 3 times 3 times 3 is 81. So I have 4 plus 81 on the top of my fraction and 7 minus 2 on the bottom. So we're still pretending that my fraction bar is a grouping symbol. So I'm dealing with everything on top and bottom first. 81 plus 4 is 85. 7 minus 2 is 5. If I divide 85 by 5, I get 17. All right. Something else we do with expressions is we evaluate them, not just simplify. When we evaluate them, we replace the variable with a given number that they will give to you. So in example A, they are telling us that x is 5 and y is 2. So you want to take the expression and you want to rewrite it. Every time you see an x, replace it with a 5. Every time you see a y, replace it with a 2. So x squared, instead of that, they put 5 squared. Plus x, plus 5. Minus 12 stays the same, minus 12. Divide by y squared. Since y is 2, it's divided by 2 squared. Then you can solve as is using your order of operations. Same thing with b. Instead of xy, they put 5 in for x and 2 in for y. Use order of operations. So let's do one together. Let's do 3b minus a squared. 3 times b, and b is 4. So 3 times 4, well that's 12. And minus a squared. A is 3, so minus 3 squared. 3 squared is 9. 12 minus 9 is 3. So that's how you evaluate an expression. All right, and sometimes we evaluate with a real-world expression or situation. Let's read this one together. What is an expression for the spending money you have left after depositing 2/5 of your wages into savings? Evaluate the expression for weekly wages of 40, 50, 75, and 100. So they want us to eventually plug these 4 numbers into an expression that we need to create. All right, so first you want to define a variable. Let's let W equal how much we make. So pretending they didn't give us these values, on a general day, we make W. And we're trying to find how much spending money we have left. So to get spending money, we take what we make, our wage, and we have to subtract what goes into the savings account. So it says that we deposit 2/5 of what we make. So that's 2/5 times our wage. If we subtract that from our original wage amount, we should get our spending money. So when you have that expression, you can put it into a table. Now we can fill our W values for whatever they want us to. So now I plug 40 into my equation, use order of operations, and I get spending money. Put 50 into my equation, get my spending money. So you just kind of plug into your expression and you get answers. Okay? All right, so I'm going to stop you there and have you work on this lesson check. Please complete 1 through 7 along with your notes and bring any questions you have about any parts of the video to class.